Problem 1 from Workbook 7b. Now, here is a formula from statistics. X bar minus z sub alpha over 2 times sigma over root n is less than or equal to mu, which is less than or equal to x bar plus z sub alpha over 2 times sigma over root n. I doubt many people at first really like formulas that look like this. But I can't have you scared of them. So I am going to ask you to plug in values. I want you to realize that each and every bit of this has its purpose. Each and every bit of it is something that you should be able to understand. In a lot of ways, this reminds me of the range rule of thumb, with a few differences. Now, the z sub alpha over 2. Before, we said take 2 standard deviations to the right, 2 standard deviations to the left. Those would be consistent with z-scores. And that should make up about 95%. So the z sub alpha over 2 you can think of as kind of being like the 2 in the range rule of thumb. We had the mu and the x bar switched. Typically we had a score on the inside and we had a mu here. The difference there is that it's really just one of the way you look at it. Are you going to say that the mean is close to the score, or that the score is close to the mean? So in this case it's just inverted. The third big change, instead of looking at a score, we're looking at a sample mean. So instead of looking at sigma here, sigma over root n is really sigma sub x bar. Sigma sub x bar, that was the standard error of the mean. So we've kind of made 3 replacements. We've replaced 2 with z sub alpha over 2 so that we can do all sorts of different confidence intervals, not just the 95% confidence interval, and it turns out that 2 wasn't quite the correct number. We also replaced x with x bar, and so we had to replace sigma with sigma sub x bar, and we inverted the formula. So instead of x bar being close to the population mean, we're saying that the population mean is close to x bar. What this allows us to do is, using a sample, try to figure out what the population mean is. We're going to try to guess a population parameter by looking at sample statistics. On to what you are going to do. First, there are some things that are easy to plug in. In the description, I'm going to tell you the sample size is 45. You're responsible for remembering that sample size is n. So here and here, I'm going to replace n with 45. You're told that the mean is 12.4. Well, the mean, the sample mean, is going to be x bar. So I have a 12.4 here. I have a 12.4 there. Remember, it's minus on one side, plus on the other side. I'll put those over. It's got a known standard deviation. If the standard deviation is known, then that's sigma. If the standard deviation comes from the sample, then that would have been an S here or here. The standard deviation is 1.06, so I'm going to put it up top here. I'm going to put it up top there. Mu is what we're looking for. Mu is going to be on the inside. So you can see how I've given you a bunch of information that you need to use to plug in, and so far I've plugged in, well, pretty close to everything. The only thing that I haven't plugged in is z sub alpha over 2. Now for that, you need to take a look at two different things. You need to take a look at the confidence interval, and you need to take a look at a distribution chart. This is a chart that I'd like you to print off. It will either be emailed to you or put in a place where you can download and print it. The only one that you need for this chapter is going to be the t distribution, critical t values. That's going to be table A3. So I'd like you to have this out and printed. Alpha is going to be your willingness to be wrong. If you're 95% confident, if P is 95%, that's 0.95. Alpha is 1 minus your confidence level. So alpha is going to be 0.05. Visually, the 95% is going to be the central 95%. It's not the 95th percentile. The 95th percentile starts from the left and collects 95% of the scores and excludes the 5% that is on the top. The central 95% splits that 5% into two pieces, a bottom half and a top half. That's why it's alpha over 2, because the alpha, the 0.05, gets cut in half and is going to be 0.025. As for what you're going to do on the table, do you see how I have a bit excluded to the left and to the right? So I have something excluded on both tails. This is naturally going to be 2 tails. So if you look at the header, you can see that the header is set up so you can look at area in one tail or area in 2 tails. We're interested in the area in 2 tails. The area in the 2 tails is going to add up to 0.05, so we're interested in this column. By the way, 0.025, the area in one tail, that's the area to the right or the area to the left. So either of these two make sense, but I want you to key off area in 2 tails. This is your alpha. It's 1 minus the confidence level. Now I realize that this is for a t distribution, and what we're going to do is actually a z distribution. But it turns out that the z distribution is something that the t distribution converges to as the sample size gets larger and larger. So eventually they just refer to it as a large sample size. Then this score on the bottom is going to be the critical z-score. It's going to be your z sub alpha over 2. Now remember that we were looking at area in 2 tails, 0.05. If I drag all the way down to the bottom, I'll get my critical z value. Now, when we were doing the range rule of thumb, the critical z value that we were using was 2. And 2 is an okay number to use, but it wasn't exactly right. The correct value, the better value, would have been 1.960. So I'm going to put in a 1.960 here and 1.960 there. Those are going to be the 2 places. As a variation, if I do ask you for t sub alpha over 2, you would have made some changes. The first change you would have made, I'm sorry, I forgot to zoom out. Let me show you what I did. I put a 1.960 here for z sub alpha over 2. I put a 1.960 here for z sub alpha over 2. And by the way, this is the answer that I want. This is the complete answer to this question. I don't want you to do the square root. I don't want you to do the arithmetic. I don't want you to simplify the left and the right. I want you to leave it all alone. This would be the final answer. If it was a t-distribution, suppose that I told you that n was 19. It turns out that the degree of freedom that you would use is always going to be n minus 1 for a simple t-distribution. So in this case, that would have been 18. Suppose I asked for the 90% confidence interval and the sample size was 19. Let's see how we would have read the chart this time. First, area in two tails. If we have 90% confidence, then that means we have 10%, I suppose you could call alpha anxiety. So we've got 10% chance of being wrong. Now, n was 19. We said degree of freedom was 18. So that's going to be this line. If I take this row across to this column, I have a number right here. And you can see that that's the number 1.734. Now that would be my t sub alpha over 2. If n is 19, then the degree of freedom is 18, 90% confidence interval, so I'm looking for area in two tails 0.10, and t sub alpha over 2 would be 1.734. That's not for this problem, but hopefully that will help you when you do the problem in the workbook, which does have the t interval instead of the z interval.